All right, here's a video on getting inside of a micro transceiver 4-band handheld HF radio. It's got a clamshell aluminum case. There's 4 screws in the top and there's 4 screws in the bottom. Take out the 2 bottom screws to the back case and take out all 4 screws to the top. And that comes off. There's your battery. This is the RF board. How do I know that? Well, let me focus in here a little bit. That's the focus board. This is the back of the RF board. This is primarily through-hole soldering components, with the exception of, I think that's an extended PIO for the Amico 328P processor chip. Okay, there's 3 screws to the RF board. Once you get that out, 3 screws out, this pops out. Rock it out carefully. Rock it out. And it slides off the top. And so what goes with it is the top board is connected it's just held on with the BNC board, which is soldered to the BNC connector, which is soldered to the board. And that's your main board. There were 3 BS130 TO92 transistors on here. They went bad on me after the first day of ownership. This is the low pass or band pass filters for these 4 bands. And I have got a scope with an FFT monitor that will show me harmonic distortion. And let me just say, the 10 meter band doesn't, 12 meters doesn't work there. It won't work on 12. It'll work on 10, sort of, and it'll work on 11, sort of. It works on 15, but not 17 or 12, only 15. It works on 20 and only 20. It works on 40, but it also seems to work a little bit on 30. It's a Mitsubishi RD15HVF something, A or B, whatever. I got it from RF Parts. They're fairly expensive. That transistor's, if I remember right, was like $16, $17 shipped. It has a unique feature. Well, first of all, it's an RF transistor. It's a MOS, and it works well with this board. The 3 BS170s would have been cheaper. Yes, they're only like 39 cents a piece. It has way more current capacity, and it has less input capacitance and less output capacitance, straight capacitance, than the BS170s have. So it should work on the higher frequencies, 10 meters, a little bit better. And that's kind of out to debate. It's not worth it. It doesn't work that much better. This is an E-class transmitter, so it doesn't need a lot of heat sinking. The BS170s weren't heat sunk. They were just through-hole mounted. This one, the source is connected to the tab, which is unique for this TO220 style. Most of the MOSFET transistors of this style, the source is hot to this, so you can't ground it. This one could be grounded, could be fastened. This board conducts heat, so it could be fastened to the board, but it doesn't really need it. Anyway, that's what I've got in there. I've tried some other transistors. This one is the most durable. It has problems in the 20 meter band. The way the bandpass filter is set up, it's not efficient. It draws a lot of drain current, and if if I plug in my 14 volt supply into it, it puts out, okay, with the batteries on 40 meters, it puts out 4 watts. I plug in the 14 volt supply, it puts out 6. On 20 meters with the batteries, it puts out 1.5 watts. And if I plug in the 14 volts, it puts out 2 watts. And apparently I did that with the BS 170s in there, the stock transistors, and along with the keyer coming on when I didn't want it to come on in CW, it took those transistors out. And I've tried it with some other small transistors. I've got some, they're not exactly 170s, but I got some MOSFET 92 style transistors. I had them in here, and I had one that worked very well. And as soon as I went to 20 meters, it took it out. But it worked good on 40 meters, and I made some contacts with it. Anyway, here's the main board, and it's done well. Oh yeah, it's out of focus too. The circuit board, it's laid out neat. There's no need to pull it out. You can, I think it's just kind of glued in. You can pull on it. I don't want to. The LCD is connected down here by this ribbon cable. I'm going to leave that alone. Don't want to harp on it. But that's a look at the inside. So anyway, I guess a quick conclusion. I should order some BS 170s and try it again. I've got I got this thing. I'll show you. Antenna analyzer. And I can plug it into this thing. These relays, let me switch this back. They are magnetic latching relays. So you can plug it into this thing, plug it back into the circuit, change the band, unplug it, and that relay will remain on. I can put a 50 ohm load here, and I can't show you right now, but I've got a cable adapter that connects from this, and I can connect to, there's a test point 1 and a ground. Test point 1 is the source, which is the input to the bandpass filters. I call them bandpass filters, but they may be a low pass filter, and ground. So I can sweep these. And what I found was that the Z impedance was, the resistance was really low on these from the antenna analyzer. And I was able to move the wires around, and I brought it up a little bit. I got it was like 13 ohms, and I got it like 40 some ohms, which is not ideal. And surprisingly, the 40 meter one wants to dip, the best place is at 6 megacycles, which is not the 40 meter band, and it can't transmit there. And I had one little transistor in here, a TO92 style transistor, that would put out 12 watts. It put out 12 watts with a power supply adapted into it. The external power supply, not the batteries. And it put out 6 watts with the internal batteries. And on 40 meters, that transistor put out 8 watts with the AC adapter, external power supply adapter on there. And then I put it on 20 meters before I corrected the impedance by moving the little wires around on the toroids, and it burned out my little transistor. And I might put that back in and take this guy back out. It didn't work well. The little transistor has more input capacitance and output capacitance, so it didn't work very well on 10. This puts out like 2.25 watts on 20, and it puts out 2.25 watts on 10, puts out 3 watts on 15, and that's, again, this is with the AC adapter at 14 volts power supply, and it puts out close to 6 watts on 40 meters. And I've made like 3-4 40 meter sideband contacts with it. So haven't made any 10 meter contacts with it yet. But and there's other things. There's other things there I should show you, and I'll have to do it in another video. Anyway, this video is on taking it apart, looking inside, hearing me rant about the low-pass filters not being the best, and hearing me rant about the finals failing, but they're easy to pull and change, and they're cheap. And that's what it's about. More you know. 7 3s.